All right, this video is going to talk a little bit about the difference between dependent and independent ideas or events on kind of fairly complex problems. And the two problems that I'm going to kind of walk you through in this video are very similar. You'll notice in the question, a student's basically taking an exam or going to take an exam, but careful how you interpret the wording. So let's look at the one on the top. A student receives a list of 20 study problems, right? So a teacher's being nice. They're saying, okay, I want you to know these 20 things. Here's 20 things to study from which 10 of them are going to make up their exam, right? So they're just going to pick 10 of those questions and put on the exam. So of course, as a student, it's always your chance. You can study 10 of them. You can study 20 of them. You can study as many as you want and just sort of hope that the ones on the exam are the ones you know. Well, a student, right, knows how to solve 15 of those problems. So they studied 15 of them. They're really confident in 15 of them. They ran out of time. They got to go take this exam. What's the probability that they get 10 correct, right? Or 8 correct? Well, the trick here is no question is going to occur twice. So once you've answered one of the questions, you know that the next question you answer is one of the other 19, which just means that the first thing that happens, right, the first exam question in some way affects whether or not you know the answer to the next exam question, right? So this is going to be a very dependent, right, idea. In which case, we can use those complements or combinations, I should say, not complements, combinations to our advantage. We know that there are, again, 15 questions that we know the answers to, and there are 5 questions that we don't know the answers to. But we're going to also choose this out of 20 questions, right? Well, of the 15 questions we know the answers to, if we're going to get 10 correct, all 10 questions better come from those 15, right? And none of the questions better come from the 5 we don't know. So essentially, the 10 questions on the exam must have been 10 questions we knew, and none of the questions we didn't. All of the possible ways the test could be considered, though, again, we're picking 10 questions out of the 20 very simply, easily, and done right there. So again, all we need to do is go ahead and type those into our calculator and figure out what those numbers, right, are going to look like. So, just a second as my calculator opens up here, we can do that. Again, if you're working with a TI, either 84 plus or sort of that 84 caliber family of calculators, right? What you're going to do is go ahead and say then, out of the 15, right, we're going to go to our math menu. We're going to go over to probability. Combinations is the third option. And we're going to choose, again, all 10 questions from there. I'm going to go ahead and get that number, so 3003. I know that, right, 5 choose 0 should be 1. And again, you can always figure that out, right? 5 choose 0 should come out to 1. So again, 3003 times 1 is just going to be 3003. And then I'm going to divide 3003, right, by 20, choose 10 questions, right? All of the ways the entire exam could have been constructed. And therefore, we get a 0.016 probability, approximately here. Right? Sorry about that. 0.016, right, probability of that happening. Well, in that case, 8 correct is kind of the same idea. We're just basically going to take 15, choose 8 of them, right? We know 8. And at the same time, well, hey, we got to have 10 total questions. That means 2 of the questions must have come from the 5 we don't know, right? We're likely to get those wrong. So again, 20, choose 10 on the bottom. That's just all the possible exams. And we should very simply be able to just go back to our calculator then and calculate those numbers. Now I'm going to take advantage of a little copy paste here because I want 15 choose 8 this time. And I'm going to multiply by, I'm going to go up here to my 5, choose 2. And then we're going to go ahead and say, well, okay, if there's that many ways to get 8 right, which makes sense. Again, there should be more ways to get 8 right and 2 wrong, right? There's a lot of combinations there. We're going to divide that by, again, 20. I'm just going to go ahead and do it the old-fashioned route here. Choose 10. And we get 0.348. 0.348. Again, for an example there. Now, the question on the bottom is worded slightly differently. A student's taking a two-question multiple choice test. There are 5 answers to each question, only one of which is correct. The student has not been paying attention to class, so they're going to guess at all of them. Well, now that's a slightly different scenario. Now we're saying, well, every question is independent of the next one. In the previous example, once we knew a question, well, that only left 19 other questions to make the exam out of. This time, we know nothing. And basically the idea is there's a 1/5 chance that we get anything correct, right? So again, the probability of being correct on any one question, right, is going to be 1/5. Often we just call that P, right? The probability of success, okay? So 1/5 chance. Well, the probability of getting both questions right then is that I got the first one right and I got the second one right. So basically 1/25, right? A chance there, or 0.04, in case you're wondering there. Probably we get them both wrong. Well, now there's a 4/5 chance we get the first one wrong. There's a 4/5 chance we get the second one wrong. Because again, they don't affect each other. These are independent, right, questions. So again, 16 out of the 25 ways, right, of making that happen. And again, if you're a big fan of those decimals, that's 0.64, right? 16 out of 25. What's probably getting exactly 1 right? Well, now here's where you have to be really careful. A lot of folks would just say, well, hey, if 1 right, that means I get 1 right. It means I must have gotten the other one wrong, which would be, again, 4/5. The problem is that means there's one scenario here, there's 16 there, so that's 17 of the 25. And if we add 4 onto that, that's 21 of the 25 ways. Well, we can't have 1 plus 16 plus 4. Again, that's only 21 ways. What happened to the other 4 ways? We said there's 25, right? On the bottom of both of these examples, there's 25 ways that we could do this. And what you have to remember is when you multiply the way we did, technically we've assumed the order. And that's why we want to take advantage of a little bit of a sort of a binomial probability, right? Binomial meaning sort of 2 events, right? Binomial, success or fail. But to know that, again, here we've assumed we've got the first question right. But to get exactly 1 right, couldn't we have had the first one wrong and gotten the second one right? Essentially, there are 2 scenarios, right, in which this can happen. Or we should say 2 choose 1. Of the 2 questions, we're going to get 1 right, which technically there are 2 ways that can happen. And our answer to this question becomes 8 out of 25, right? 8 out of 25 possible ways here. Because again, this should be an 8 possibilities, right, of the 25 possibilities happening, right? 25 possible ways we could answer the test, right, with 5 questions or 5 options on each question. This again is a binomial idea because it's independent. Because it's independent and we have a chance of either success or fail, we want to think of the fact that, again, the order in which we have a success or fail shouldn't matter. We need to consider those orders. We need that combination at the beginning. I hope that helps you understand the difference between sort of dependent probabilities and independent probabilities, where they might be a little more complex, where we might have to kind of think through a lot of different scenarios. If you have any questions about that, make sure you talk to your teacher. Watch more videos about binomial probability or possibly just dependent probabilities, and have a great day.